All right, in our last module, the big question was what direction should we go from our current point to make our objective function better? We were often minimizing, so we'd want to make the objective function smaller. And we said the negative gradient is the direction of steepest descent, so let's go that direction. So the question is now, how far should we go? And our first idea, idea number 0, is just go as far as the current gradient takes us. So just take our current value and add the gradient to it, a current location, this is a vector, and add the current gradient to it, and that'll be our new location, and then we'll compute the new gradient, and then take another step and keep going. So that gives us this function, which I'm calling steepest descent 0, because it's our idea number 0. And we're just saying pass in some starting coefficients, tell us how many steps you want to take. Here we're doing this in the context of linear regression, so we're passing in the regression data. And we just say, okay, do a for loop for however many steps we were told to do, get the function value at the current coefficients, get the derivative at the current coefficients, the gradient. Here we're saving these so we can graph them later. And then here's our big update step. Take the current coefficients, the current position or x value, and just add the negative gradient, and that's our new position, and just keep doing that, and then give back all this stuff. So what do we get when we actually run this? We'll tell it to run for 40 steps. We'll tell it to start at 0, 0. The data set we're using here has a optimal slope of 0.5 and an optimal intercept of 0.7, so we're deliberately not starting right at the exact right values. And let's take a look at the history of the objective function values. So starting at 0, 0, our mean squared residual is that, and then after one step it's 10 to the 4th, and then after another step it's 10 to the 8th. This is not looking like we're doing a good job minimizing, is it? After 40 steps it's 10 to the 140th. Well, let's take a look at what the coefficients are doing. Here's the first 10 steps in that history of coefficients. And just looking at this, we can see the coefficients are getting bigger. And interestingly enough, they're bouncing back and forth between negative and positive, both the both the current estimate of the intercept and the current estimate of the slope. So overall, we are not doing a good job minimizing, and we need to think of what might be happening here. How can we fix it? So one thing we could have done before that we didn't do, when we were looking at the contours of the objective function and the gradient arrows, the graph looked like this, but that's because it auto-scaled the arrows. The Python code for plotting this arrow vector field auto-scales things. If we tell it to not auto-scale things, we get this showing the gradients. These gradients are huge, right? They're going off the screen. So if I started 0, 0 here, the gradient goes way down here, following the negative gradient would take me way up here, kind of across the middle of the valley, and up the other side of the hill, possibly even up higher than I was over here, and then the gradient would be even stronger coming back the other way, so we would end up just oscillating back and forth, getting worse and worse each time. So that's really what's going on. It's interesting we have these apparently random looking gradient arrows. I think that's just when the points we're evaluating it at just happen to cross over from one side to the other. I wouldn't really worry about those. So take a minute at the end of this video to think what's a better idea than our idea number 0 of just going however far the gradient apparently says to go, and then we'll start the next video. One quick thing to note, in retrospect, if we had thought about units, like kilometers, miles, and stuff, the units of the current position are probably not the same as the units of the gradient. Like if I'm trying to minimize number of life years lost in some medical situation by giving people medicine that's measured in milligrams, the x values would be measured in milligrams, and the objective function would be measured in lives lost, or life years lost. We're trying to minimize that. The units of the gradient would be like life years lost per unit of per milligram of this medicine or that medicine. So it would be life years per milligram here, but milligrams over here. So anytime the units aren't matching, you can kind of bet that things won't work out well. Now we'll go on to the next video and talk about maybe a solution.